Hi guys, today we're going to be talking about angles and trigonometry and just have a little introduction to that. So we're going to start by talking about an angle of rotation. An angle of rotation is an angle formed by the starting and ending positions of a ray. Remember, ray is just kind of a point extended there. That rotates about its endpoint. And we're going to draw a picture of what that looks like in just a moment. But I also want to talk about standard position because usually we start these angles of rotations in standard position. And that standard position is where the vertex of the angle is at the origin. So again, origin starting in the center there. And the initial side is on our x axis. So here we have our x-axis, there's our y. So our initial ray, our starting is here. This is our initial side. And then this is in standard position. We can have another ray pointing out, and this ray could be pointed anywhere, but I just decided to put it there. And this is what it's called, our terminal side. And then this angle here, you can see how we rotated the ray, and that's what we call theta. It's a Greek letter. If you want to like spell it out using English, it's theta. And there we have a angle of rotation demonstrated here in standard position. This angle theta is going to be greater than 0 or have a positive measure when you are rotating counterclockwise. So you're going where this arrow is kind of pointed. So that's counterclockwise. And then we also have this opposite situation where we're going to have to think about what type of measure is our angle going to have if we rotate clockwise. Well, it's going to naturally be the opposite. We're going to have a negative measure. So we're going to have a less than symbol there. And it's going to give us a negative measure when we go this other way, rotating clockwise. So let's see an example of this positive and negative theta in action. So I'm going to have an angle here with starting from standard position, and we're going to talk about the angle of rotation and talk about its measure. Before we get into the specifics of it, I want to help us get some bearings about our quadrants, and we're going to actually use some specific degrees here. So when we have anything on this x-axis here, it's going to start at 0 degrees. As you rotate up, we can see this is a 90-degree angle. So this is 90 degrees. Over here, we have another 90-degree angle. So it's 180 degrees. We're going another 90 degrees. So this is 270, 70 degrees. And then as you go all the way back to your original location, you're rotating another 90 degrees. So if you're coming from this way, it's 360 degrees. We also do name these quadrants, so it's good to know as we're getting our bearings. This is quadrant 1, 2, 3, and finally 4. And you usually see these in Roman numerals, just so I'm writing them that way as well. So let's get into more of the nitty-gritty of this particular angle here. I'm going to say, and this is, again, an estimation. This is not necessarily exact, but I'm over here. So this is in the positive direction. I'm going to have to be between somewhere of 180 and 270 degrees. Let's just say this is 257 degrees in the positive direction when we're rotating counterclockwise. But let's say we also want to find its negative counterpart going from here to here. So if we're going from there to there to find this negative counterpart, there's a few ways we can do it. We can kind of add up 90 and go this way, but I think the easiest way is, well, this whole thing is 360 degrees, and then we're taking away this kind of part of the pie, So we're taking away 257, and that should give us what's left of this little section here. And so that's equal to 103 degrees, but since it's in the clockwise direction, it's going to be negative 103 degrees for that measure. So this 257 degrees and this negative 103 degrees are special. We have a special word to call them. So 257 degrees and negative 103 degrees, we call them coterminal. And what coterminal means is that they're angles that share the same terminal side. We have the same terminal side right there. And there can be obviously more than one coterminal angle because we can see we have two here. And we're going to see another example down here and explore coterminal angles some more. So 60 degrees, I'm going to draw my terminal side here because 60 degrees is going to be between 0 degrees and 90 degrees. So in our first quadrant here, again, this is not particularly exact. It's roughly about there. Doesn't have to be perfect. I'm not measuring it right now. It's not a skill we're thinking about right now. So we have, when you think about this red, we're going counterclockwise. We have that 60 degrees. We can also have it going the other way, like we just talked about, to find its coterminal angle going this way. And of course, we can find that by the same way we did before. You can take 360 degrees and subtract the 60 degrees from it to get that this is 300 degrees. But again, it's going to be negative because it's clockwise. And so we have some coterminal angles. We have our 60 degrees and we have our negative 300 degrees. But those are not our only coterminal angles. Let's say I decided to draw another arrow where, I'm not going to use that color, I want this color. I'm going around, so that's one full rotation, that's 360 degrees, and then I go another 60. Just because I'm going around, it's still a different angle, but here, instead of going just 60 degrees, I added another 360. So I can have 60 plus 360, and that's a different angle, but it has the same terminal side. So they are coterminal, and I can have a 420 degree angle that is coterminal as well. I could also go as far to go the other way. I could go around again and then around again, and I can have another negative coterminal angle there. So these angles can be adding on and on and on. And we can do that by adding specifically another full rotation. And that full rotation is that 360 degrees. So we can get more coterminal angles and I'm going to abbreviate like that, angles, by adding, and you could do 360 or multiples of 360 degrees. But we also have to consider the other way around. What if I went this way an extra 360 degrees? That would be going negative direction, so that'd be the same as subtracting. So to find different coterminal angles, more than just our basic two that we have here in red and blue, we can find more that are larger, like 420. We can add another 360, and we can get 780 degrees. That's another coterminal angle. We could subtract and get another coterminal angle that way. So let's see another example here, and we'll do this one together. So we're going to draw an angle that is 310 degrees, and then we're going to find an angle that's coterminal to it. So first, I want to get some bearings down. So put where some of my degrees are. So 310 is going to be between 270 and 360. So I'm going to put it right about here. Again, doesn't have to be perfect. So that is in the positive direction from my initial side there to my terminal side, that's the 310 degrees. And then again, we want to find a coterminal angle. So of course we can do the other component of it. We can go clockwise and get the negative side. So to get the negative side, it's going to be 360 minus 310. So that's going to be 50. And it's going to be negative because we're going in that direction. And then there we have it. We have a coterminal angle to 310. So 310 degrees is coterminal to negative 50 degrees. But let's say I wanted another positive. If I wanted another positive coterminal angle, I can go around and around again. And what I did there is just added 360 degrees. So 360 degrees is, plus 310 degrees is going to give me 670 degrees. So that's my 670 degrees there in the pink. So 310 is coterminal to negative 50 and 370 degrees. And of course, you can continue going the other way in the negative direction if you wanted to as well. We could do, and I'm actually not going to draw this one because it's going to get too many swirls. But if you go around and around again, so it's going to be, you're subtracting another 360 from the negative 50, you could get that you get negative 410 degrees. So all of these are coterminal angles, and you could continue to do that and do different multiples of 360 by adding or subtracting them. So kind of in conclusion there, we can say that there are an infinite amount of coterminal angles to 310 degrees, or honestly, to any angle for that matter. So good things to think about. Now, I would like you guys to pause the video and give this one a try. So draw an angle of 150 degrees and find a positive and a negative coterminal angle. So here is your 150 degree angle. Again, not exact, but it's between 90 and 180, so that's good for right now. And then that's your 150 degree in the red. And then we also can have an addition of 360 degrees to get a different positive coterminal angle. So you go around once, and again back to the 150. So 150 plus 360 is a coterminal angle of 510 degrees. And then we could also do the subtraction of 360 from 150 to get the negative 210 degrees, which is shown here in the blue. So those are basic examples. Of course, you could have added different multiples of 360. You could add a 720 or subtract a 720, etc. But there is that.